Let's look at an optimization problem that involves a distance. Consider this function f of x equals x squared, and then just some point, 3, 2. Now, 3, 2, of course, is not on the curve of f of x equals x squared. But let's suppose that we want to find a point on this curve, on this parabola, that is the closest of all the points on this parabola to this point. We want to find the point, the one point on this curve that minimizes the distance from the curve to this point. Well, let's draw a picture of what we're looking for here. We've got a parabola, here, a parabola, and we've got a point right here at this 3, 2. And we're trying to find the point on this curve. I'll just call it xy. That is the closest of all these points to that point. Well, we're dealing with distance. So the distance formula, remember, is the square root of the difference of the x's, you know, the x on this curve to this x, plus the y on this curve minus the y. There. The distance. That is the distance. What we want to do is we want to find the minimum value of that. Well, one of the things that troubles us about this is that we know we're going to have to be doing some differentiation. And we get a radical in there. We don't like the radical. So let's do this. Let's substitute, let's instead of minimizing the distance, let's just talk about the squared distance. In other words, let's get rid of the radical altogether. Because really, if I minimize the squared distance, that's going to give us the same result. It's going to give us the same xy. And it'll just be a little easier. Now, something else that troubles us is the fact that we've got a y in here. Well, we can use the function, right? Y equals x squared. Because f of x equals x squared, that's just, you know, y equals x squared. Yeah. So let's, in place of y, put x squared. So here we go. We've got now g of x is equal to x minus 3 squared. See that? Plus x squared minus 2 squared. Yeah, no worries. Well, it looks like now we have something we can differentiate. So let's go with that. Let's see what we've got now. I'm just going to go through here and differentiate. So here I go. I've got g prime of x is equal to 2 times x minus 3. See? Derivative of the outside times the derivative of the inside, but the derivative of the inside is just 1. Plus, let's see here, 2 times x squared minus 2 times 2x, using the chain rule there. Okay, so I just use the chain rule. Okay, now what I need to do, I've differentiated this. Now I need to see if I can maybe add like terms, simplify a little bit. Let's see what I can do. So I clear my parentheses. So this is going to be 2x minus 6 from right here. And let's see what else we got here. This is 2x times 2. That's 4x times x squared. That's 4x cubed. 4x cubed. See that? Minus, there's 2 times 2 is 4, times 2 is 8x. Yeah, there we go. Okay, so let's see what that gives us. That's going to give us 4x cubed minus 6x. See that? Minus 6x minus 6. And we set all that equal to 0. So let's just make sure. 4x cubed minus 6x minus 6. Yeah, there it is. That's got it. Okay, now this is one that we have to solve. We have to solve this for x, and that will give us what we're looking for. But look, I've got a 2 in here. I might as well divide that out. So I've got 2x cubed minus 3x minus 3 equals 0. So we've got to figure out how to solve that. So we have this 2x cubed minus 3x minus 3 equals 0. So that one gives us fits if we try to solve it algebraically. So we revert to a graphing method. And in this case, I plugged it into Desmos. I've got 2x cubed minus 3x minus 3. And I just come over here and put my arrow about where I think it crosses the axis. In other words, that's what we're looking for when we solve graphically. We're looking for where it crosses the axis, and there it is. 1.567 comma 0. Yeah, that's what we're looking for. So I've solved that. In other words, what I've done is I found the x-coordinate that will minimize of the point that is closest to that point 3,2. So now I'm going to plot that point right here. Notice I've went ahead and put it in 1.567 comma f of 1.567. So let me plot that, and let me turn this thing off and turn on my function. Okay, so here's my function. Here's x squared, and here's the point that we say is the closest to this point. See, there it is. So that's what we wanted to find. We wanted to find the point on this curve that is absolute closest to this point right here. And this looks reasonable, right? Yeah, so we've done it.